Hi class, so today I'm going to go over the 9 questions that are on the review sheet, and I'm going to go through them one by one, and I hope this is helpful to you in your preparation for your exam tomorrow, on Friday, October 3rd. Okay, so the first question says, explain in paragraph form how sand, salt, and iron could be separated from each other. So remember that you first used a magnet to separate the iron out, then you used a filter to separate the sand from the salt, and then you dried the sand, and then there was some subtraction that was involved to get the mass of the salt. So a group in third period wrote a reasonable answer, and we'll read that together here. To separate sand, salt, and iron, you first can take a magnet in a plastic bag and hold it above the mixture. Iron is the only magnetic substance, so it'll be the only one to separate. Then determine the mass after that. So you're weighing the iron that's pulled out. So now you're left with salt and sand. Mix the sand and salt in a beaker of water so the salt will dissolve. Pour the sand and water into a filter in a funnel above a beaker. The sand should stay at the top of the filter, so the sand gets stuck in the filter paper, while the salt water runs through the filter paper into the beaker. While the salt water runs through the filter into the beaker, okay, so they said that. Take the filter out of the funnel and place it on a table to dry overnight. After it's dried, you weigh the sand, and then this part where it says determine the mass of the salt, the way this was done is you take the total mass from the beginning, and you subtract the mass of the sand, and you subtract the mass of the iron, and you have the total mass, and what that gets you is the mass of the salt. So you would explain that in a sentence. So in general, this group from third period actually did quite a good job. Okay, the next question, which is number 2, calculate the mass percentage of each component in a mixture: 241 grams of sand, 118 grams of iron, and 529 grams of salt. So remember, the equation is the mass percent equals the mass of the component that you want to talk about over the mass of the total times 100%. Okay, so you're doing this calculation 3 times. So on the first one, we're trying to find the percentage of the salt. You write 241 grams of sand, and you divide that by the total. So you have to add up that number, and that number. So, and a group in third period got 888 grams total. I'm just using their number. And then you take that and multiply by 100%. And then you plug that into your calculator, and you get the answer. Same thing for the other ones. 118 grams of iron divided by 888 grams total times 100%, and you get your answer. Now remember, your answer should always be, say, percent sand, or say percent iron. Or in the last example, we were doing 529 grams of salt. You're dividing it by 888 grams total, multiplying it by 100%, and you're getting the percent of salt. Now, I'm not doing the calculations because I'm sure that all of you can hit these buttons in a calculator. Okay? Okay, number 3. It's essentially the same thing. So, but you're doing it in reverse. Here we're given the percentages, and we're given the total mass. So, you take 18% salt, you got to divide by 100 to get the decimal. We multiply by the total, and we get our grams of salt. You do the same thing for sand, 57% sand, divided by 100% to get to the decimal. You multiply 100 by 185 grams total, and you get the grams of sand. And in the last one, you have 25% iron divided by 100%, You multiply by 185 grams total, and you get the grams of iron. So again, I haven't typed this into my calculator because I'm sure that you can divide and multiply these numbers in a calculator yourself. So in number 4, it says draw a graduated cylinder, a funnel, an electronic balance, a striker, and tongs. Write the purpose of each. So I'm going to do a quick, really terrible drawing of each one. Here is a beaker. A beaker holds liquid so that you can use it for some experimental purpose. A graduated cylinder is used to measure the volume of a liquid, and this is kind of what a graduated cylinder looks like. A funnel is used to, usually a filter paper goes in there, and you can filter samples. You can also make sure you can deliver liquids easily into a smaller container using a funnel, something that has a small hole in the top of a jar, for example. An electronic balance kind of looks a little bit like this, with a little readout on it, and it's used to determine the mass of a substance. A striker looks something like that, and it has a little thing here. So the striker it creates a spark, so you can create a fire. And then you have tongs, which kind of look like that. They kind of look like scissors, but no sharp end. And you can pick up hot substances with tongs. In number 5, it says, what is the volume of the liquid in this graduated cylinder? Remember, you have to measure the bottom of the liquid right here, and that's called the meniscus. And when you do that, you can see that this line here is 21, and that line is 22, and that line is 23, and that line is 24. So you see the liquid is halfway in between 21 and 22. It's actually sitting right on this line right there. So I would say that one is 21.5 milliliters. Okay, number 6 says, what is the size of this paper clip? So you see it's between 2 and 3, and you would guess that digit, so it would be 2.3 centimeters. In number 7, it says normal human body temperature is 37 degrees Celsius. A student measured a classmate's temperature as 38.6 degrees Celsius. What is the percent error? So the equation for this is percent error equals measured minus actual, and you take the absolute value of that, right? Turn negatives into positives, and divide by actual, and multiply by 100%. So all we're doing is plugging this into this equation. So the measured is 38.6 degrees Celsius minus 37 degrees Celsius. You take the absolute value of that, and you divide by and you divide by 37 degrees Celsius, and you multiply it by 100%. 38.6 minus 37 is 1.6 degrees Celsius divided by 37 times 100%, and you should get an answer. Again, I won't do it because you can type these in your calculators, but that's your percent error. It's something like 4.6 or 4.7% from my memory. Okay? Okay, so in number 8, it says identify the dependent and independent variables from this scenario. An experiment was done to discover the right amount of water to use on a plant. 10 seeds were planted in each of the 5 pots found around the house that contained 500 grams of peats potting soil. The pots were given the following amounts of distilled water each day for 40 days. Pot 1 is 50 milliliters, pot 2 is 100, pot 3 is 150, pot 4 is 200, pot 5 is 250 milliliters. The height of each plant was measured at the end of the experiment. So you're supposed to have learned in the observation experiment lab what an independent variable is and a dependent variable. An independent variable is, if you look this up, it will say an independent variable is what the scientist changes. The dependent variable is what the scientist measures. Okay? So if you look at this, what did the scientist change? The scientist changed the amount of water. the dependent variable, what the scientists measured is the height of the plants. Okay, and now, okay, the last question here, number 9. From the following graph and chart, what is the identity of the metal in question? So from the density lab and the post-lab questions, you're supposed to have learned that density is mass divided by volume. So you notice you have a straight line, and in this lab you're supposed to have generated a straight line for your data. It's okay if it wasn't, but ideally it should turn out this way. And all you do is you take the slope of this line. Notice mass is the y-axis, volume is the x-axis. So if you take y over x, right, from math class you would learn that change in y over change in x is the slope. But we also know that this has to go through 0 because something that has no mass is going to have no volume, right? If it doesn't weigh anything, it's not going to take up any space. So you just have to really find the density of any point here. So you see that this is about 90 grams, right? So you take 90 grams, and this is about 8 centimeters cubed, and you divide those, and you have to match it up. So if you do 90 divided by 8, we get 11 point something, right? Again, you can do this in your calculator. You get the units grams per centimeter cubed, and we would get the answer lead is the most likely substance that was coming from this data. I hope that this video helped you prepare for the test on Friday. And if you have any questions, please text me or email me. Thanks. Bye.